This is Geometry, Chapter 1, Section 1. So this is 1-1 for geometry. Okay, so first off, we're going to go through some definitions. Definitions are really important, especially for geometry, because we're going to be using these definitions time after time. So we need to get these down pat for the first chapter, and then we can use these definitions throughout the entire rest of the year. So, what is a point? A point has no shape or size. Has no shape or size. It is also a location. Is a location. Think about when you do like a map quest or maps and you drop the pin. That's a point. You're listing a point. Also with points, when we label them, so if I have a picture up here, this is a point. We're going to call that point P. When you label them, labeling. When you label them, it's going to be with a capital letter. Okay, so that's how you're going to label a point. Next is a line. So this would actually be point P. So next is a line. A line is comprised of points. I had an art teacher explain it once to me that you're taking a dot for a walk, which means that a line has infinitely many number of points. A line has no width because if it has no size or shape, a point doesn't. Obviously, if a line is made up of points, it's going to have no width. Along with that, there is exactly one line through any 2 points. Think about when you do a map. You have at least one way of getting there. You have one line from point A to point B on a map. You have one line that will get you there. It's going to be a straight line. So that is a line. It is comprised of points. Again, we're going to label it. So for labeling for a line, imagine we have a line here. We have points A and B on this line. Also, so this line can be called AB with a little line with arrows on each end over top of it. That's one way to name it. Otherwise, sometimes our book will use cursive letters, so we can call this line M. So we want to use line M. So it is a cursive lowercase letter. Okay, now we have points and we have lines. What's next? Next is planes. Okay, so planes. Planes is a flat surface made up of points that extends infinitely in all directions. So planes are made up of points. Similar to a line. Planes. Wherever there's exactly 3 points, not on the same line, there is exactly one plane. So we are going to write that as exactly one plane. There's exactly one plane through any 3 points, not on the same line. So there is exact leave one plane through any 3 points not on a line. What that means is if we have, let's name this point A, point B, point C. If I can draw a straight line through this, that's not considered a plane because that's a point and a line, not a plane. Now, if I have an A here, a B here, and a C down here, there's no way I can make a straight line with that. So how am I going to do it? I'm going to connect them, and voila, we have a plane. So there's exactly one plane through any 3 points. Also with a plane, now we need to go through labeling, just like we did with the others. So how do we label? Labeling a plane. So imagine I have a plane here. We're going to just do a parallelogram. We have our plane here. It contains 3 points. Point A, point B, point C. How can we label that? We can label it as plane A, B, C. So we can label it with 3 points in the plane. Otherwise, sometimes our book will use a capital script ladder. So we can also call this plane. Okay. Now, is this also plane CAB or BCA? Of course. It doesn't matter how you write the points. The points can be in any order as long as if they're all contained inside the plane. Now, we are going to talk about coplanar and collinear. Now that we know what a line and a plane are, we're going to talk about what that means. So, coplanar. Definition of coplanar. So we have coplanar and we have collinear. We're going to start with collinear because we started with lines. Lines then become planes. Okay, so we start with points. Points become lines. Lines become planes. It's kind of the process of how we do it. So collinear. Collinear means the points that lie on the same line. That's the definition of collinear. Coplanar. I'm sure you guys can guess. It's very similar to collinear. It's points that lie in the same plane. Okay. We have one more definition. We are going to talk about intersections. You can kind of think of this like an intersection on a road. You have 2 roads, a road here, a road here. Roads are considered lines. Kind of think about that. The ground is the plane. The roads are the lines on the plane. So when 2 lines, I'm going to write the intersection of 2 lines. What does the intersection of 2 lines meet at? It goes down, so it's a point. We started with points, went to lines, lines went to planes. We're going the opposite direction. When they meet, they go back one. So a plane So what happens when two planes meet? You get a line. Okay, example of this. So we have a road here. Imagine the road going north and south. We also have a road going east and west. So we're going to name this W for west, E for east, N for north, S for south. Where do they meet? They meet right here, right at the middle. This is the intersection. This is point P. We can label that however. We just need to label it properly with our labeling that we learned about points. So this is intersection at point P. Okay, now we have two planes. Imagine we have two planes. So I have a piece of paper here. Now I have a piece of paper here. It comes all the way down over. Okay. This line right there is the intersection. Okay? If I were to take, let's say I have this note card here. This is a plane, right? Now if I bend it in half, how many planes am I going to have? Bend it in half. I have one plane here and one plane here. You can see that crease, that's a line. That's how you can kind of think of points and lines and planes. So, now, what are we going to do with this? This is important because, let's think about this. Okay, think about your school or your house. You have a floor plan, right? So we're going to think about the floor plan of a school. We're going to think about the real life application, the floor plan of the school. So we're thinking of the floor. The floor is our plane. So the floor is a plane. Floor is a plane. You can kind of think of the hallways as lines, right? As lines. And then we'll think of the people as points. Okay, so with coplanar, let's think about this. We know what coplanar is, points that lie in the same plane. So during the school day, all the students that are in school, are they coplanar? Yes, because they are all on the floor of the school. They are inside of the plane, which is the floor of the school. Now, it's after school. Everyone goes out after school. We have the volleyball girls in here for practice, and we have the football players practicing outside. Are all the sports teams that are part of the school, are they coplanar? No, the football team is not. The football team is not practicing inside. So the football team is not coplanar. But is the volleyball team? Yeah, the volleyball team is coplanar because they are on the gym floor, which is part of the school. So they are coplanar. This is a real life example of coplanar and points, lines, and planes. Now let's think of other points. First off, let's think of other points. What are some examples of points? Maybe the tip of your pencil that you're writing with. If you sew, that tip of the needle. Any other examples that you can think of? When you draw a thumbtack has a point on it, right? Okay, now we're gonna think of lines. An example of a line might be when I'm pointing a laser pointer, the ones that like cats chase and everything. If I'm pointing that, the beam that's coming out of the laser pointer is a line. So that's the beam of a laser pointer. but what do you only really see the point of the laser pointer. So we actually see the point of the laser. So we're going to call that a laser point. Okay, what's another example of a line? We mentioned streets. That's a real life example of a line. There's plenty of other examples. This is a line. This is where two planes intersect. It meets at a line. There's plenty of other examples of a line. There's tons of planes in the real world. Think about the floor. Think about the ceiling. Now, what happens if two planes are at different levels? So imagine that I have two sheets of paper here, right? I have 3 sheets of paper actually. Okay, so this plane is right here. I have another plane that's right here. If these two planes can be at different levels, can lines be at 2 different levels? No, lines are on a flat surface. So it'd be like here and here. But planes can be at different levels. That's why airplanes, if they're flying, they can go and miss each other because they're on 2 different horizontal planes. However, imagine a car. Car's driving. We have a road here, right? Imagine an intersection. If I'm coming this way and another car is coming this way, why are we going to collide? Because we're on the same plane. There's no way that cars can somehow miraculously create 2 different planes. They are on lines. They have to be on that line, and you can't create other lines. Okay. That wraps up section 1.1. I'm going to do section 2 next. You'll see that video on following this. So, thanks for watching.